Betelgeuse, a huge red supergiant star inside the Orion constellation, is an entrancing celestial body that has long charmed astronomers and astrophysicists alike. If it were placed at the center of our solar system, its dimensions would surpass the orbit of Jupiter, even overshadowing the Sun. This titanic star, with its massive size and ongoing significant changes, might potentially lead to a cataclysmic event on a grand scale. Scientists, including notable experts like Brian Cox, have raised concerns about Betelgeuse, as it has been emitting peculiar signals throughout space. These developments have sparked a critical question. Could we be on the verge of witnessing a stellar explosion that would drastically alter the appearance of the night sky? The mystery of Betelgeuse remains a constant source of fascination for the scientific community. Like living organisms, stars are born, live, and die in ways that often challenge our understanding. Betelgeuse, a red supergiant, resides on the fringes of our galaxy and has drawn considerable interest due to its enormous size and ancient age. Its red tint and variable brightness have captured the attention of both amateur and professional astronomers over the years. The fluctuations in its brightness and color changes have piqued curiosity, but recent events have heightened questions about its future. As Betelgeuse approaches the end of its life cycle, its colossal size becomes evident. It is approximately 900 times larger than the Sun. In fact, if it were to replace the Sun, its outer layers would extend well beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars in the process. This extraordinary size reflects its current stage in the stellar evolutionary cycle. Having exhausted the hydrogen in its core, Betelgeuse is now expanding and cooling, signaling that its end is approaching. Betelgeuse is estimated to be between 8 and 8.5 million years old. While this may seem young by human standards, it is quite ancient in terms of stellar lifetimes. Over millions of years, this star has undergone dramatic changes, transitioning from a hot blue star to the cooler red supergiant it is today. These changes are driven by the balance between nuclear fusion and gravitational forces, causing stars to expand and contract throughout their lifetimes. The red hue of Betelgeuse is the result of its lower surface temperature compared to hotter stars like the Sun. While the Sun's surface temperature is approximately 5,500 Kelvin, Betelgeuse's temperature is much cooler, around 3,500 Kelvin. This cooler temperature causes Betelgeuse to emit light at longer wavelengths, giving it its distinctive red appearance. However, this color shift is not merely a cosmetic feature. It provides astronomers with valuable insights into the internal processes of the star and its ongoing evolution. Betelgeuse's color and brightness have not remained constant over time. Ancient civilizations, including the Romans and Chinese, once described the star as yellow. It was not until the 9th century that Arabic astronomers noted its shift to red. This change in color marks the star's natural progression from a hotter, younger state to the cooler red giant that we observe today. In addition to its changing color, Betelgeuse is classified as a variable star, meaning its brightness fluctuates over time. These variations can occur in both short-term cycles lasting days and longer-term patterns spanning years. The variability in Betelgeuse's brightness only adds to its mystery. Unlike other stars that show predictable brightness patterns, Betelgeuse sometimes deviates from these patterns, suggesting that complex, yet-to-be-understood processes might be occurring within it. One of the most striking events in recent history was the dramatic dimming of Betelgeuse in 2019, dubbed the Great Dimming. This mysterious event sent shockwaves through the scientific community as Betelgeuse, typically one of the brightest objects in the night sky, lost a significant amount of its brightness. Its luminosity decreased at a rate of 0.01 magnitudes per day, reaching its dimmest point in February 2020. This exceptional change raised numerous questions about the star's behavior. One challenge in studying Betelgeuse lies in the time delay between an event and its observation on Earth. The light from Betelgeuse takes over 725 years to reach our planet. Thus, when we observe the star, we are essentially seeing how it appeared in the past, not in real time. This time delay complicates efforts to track rapid changes in the star's behavior, making it difficult to predict or explain its fluctuations. In response to these unusual observations, astronomers, including Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics, have been closely monitoring Betelgeuse using advanced instruments like the Hubble Space Telescope. These observations have provided crucial insights into the changes occurring in the outer layers of Betelgeuse's atmosphere. Data from the Hubble Space Telescope revealed that material was being ejected from the star at speeds of up to 200,000 miles per hour, forming a dust cloud that partially obscured the star's surface and contributed to its dimming. This recent mass loss has led some scientists to speculate that Betelgeuse might be nearing a much more dramatic event, a supernova. The central question now is whether Betelgeuse is on the brink of exploding in a supernova. A supernova represents the violent death of a star, and if Betelgeuse were to reach this stage, its explosion would produce an incredibly bright burst of light, visible even during the day. This event would outshine the full moon and offer a unique opportunity to study the final moments of a massive star's life. However, despite the spectacular nature of such an explosion, Betelgeuse's distance from Earth, approximately 725 light-years, ensures that no direct harm would result from the event. Several theories have been proposed to explain Betelgeuse's recent dimming. One hypothesis is that it marks the beginning of the star's transition into a supernova. Another possibility is that a dust cloud formed by the star's ongoing material loss is obstructing its light. Some researchers suggest that the dimming could result from changes in Betelgeuse's outer layer or photosphere, possibly due to the formation of a large dark spot on its surface. Regardless of the cause, Betelgeuse's dimming remains a significant area of focus for astronomers. Red supergiants like Betelgeuse are crucial to our understanding of stellar evolution. These stars represent the final stage of a massive star's life before it explodes in a supernova. Their immense size and relatively short lifespans make them ideal subjects for studying the processes that lead to a star's death. Moreover, the energy released by these stars during their final stages contributes to the formation of heavy elements, which are essential for creating planets and life as we know it. If Betelgeuse were to explode, it would provide an extraordinary opportunity to observe a supernova up close. Supernovae not only serve as inspiring cosmic events but also play a key role in enriching the interstellar medium with heavy elements. When a massive star like Betelgeuse explodes, it releases elements such as iron, carbon, and oxygen, the building blocks for new planets, stars, and possibly life itself. Betelgeuse's explosion, if it were to occur, would contribute to this cosmic cycle, enhancing the interstellar medium and paving the way for new star systems. The shock waves from a supernova can compress nearby gas clouds, triggering the formation of new stars. Additionally, the radiation released during the explosion can influence the chemical composition of these stars and planets. Understanding these processes is critical for grasping the future of the universe and the intricate relationships between star deaths and the creation of new celestial bodies. As Betelgeuse continues to evolve and exhibit unusual behavior, astronomers will intensify their efforts to study it using advanced instruments like the Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories. These real-time observations will provide vital data that will improve our models of stellar evolution, particularly for red supergiants. The mass loss observed in Betelgeuse offers a glimpse into the extreme conditions experienced by red supergiants. As the star approaches the end of its life, its outer layers are expected to become even more unstable, shedding greater amounts of material. Understanding this mass loss is essential for predicting how other red supergiants will evolve and behave in their final stages. Supernovae are not just awe-inspiring cosmic events, they are fundamental to the creation of heavy elements throughout the universe. When a massive star like Betelgeuse explodes, it enriches the interstellar medium, contributing to the formation of new stars and planets. This process is essential for the cosmic recycling that sustains galaxies and provides the building blocks for life. If and when Betelgeuse undergoes a supernova, it will be an extraordinary event for astronomers and astrophysicists worldwide. It would not only offer a rare, up-close glimpse into the death of a massive star, but also provide crucial data to refine our understanding of stellar evolution and the life cycle of stars. While Betelgeuse's vast distance from Earth ensures our safety from harmful effects, its eventual explosion would leave an indelible mark on the night sky. For months, the brightness of the supernova would rival that of the full moon, providing a spectacular display visible to the naked eye. This event would also serve as a reminder of the dynamic and ever-changing nature of the universe. For now, Betelgeuse remains an enigmatic and captivating star, captivating the attention of both scientists and stargazers alike. Its behavior, fluctuations, and potential future hold valuable insights into the larger processes governing the life and death of stars. As we continue to study this iconic red supergiant, we not only deepen our understanding of the cosmos, but also enrich our appreciation for the intricate and interconnected workings of the universe. The potential supernova of Betelgeuse will likely become one of the most significant astronomical events in modern history. For centuries, astronomers have speculated on the life cycle of massive stars, and a supernova so close to Earth would provide unparalleled data for scientific research. By observing the explosion and its aftermath, scientists could gather valuable insights into the physics of stellar interiors, the processes that lead to core collapse, and the mechanisms behind the creation of heavy elements. In the aftermath of a supernova, the remnants of the exploded star often form fascinating structures, such as neutron stars, pulsars, or black holes. If Betelgeuse were to explode, its core could collapse into one of these exotic objects. A neutron star or pulsar would be a dense, rapidly spinning core left behind, while a black hole would result from a complete collapse of gravity, forming one of the universe's most mysterious phenomena. Observing such a remnant in real time would allow scientists to study these cosmic objects at an unprecedented level of detail. Another intriguing aspect of a potential Betelgeuse supernova is the effect it would have on its surrounding interstellar environment. The shock waves from the explosion would ripple through nearby gas clouds, compressing and heating them. This process could trigger the birth of new stars, giving rise to a new generation of stellar systems. Such events showcase the cyclical nature of the universe, where the death of one star paves the way for the creation of others. From a cultural perspective, the supernova of Betelgeuse would undoubtedly become a global phenomenon. Visible to the naked eye, it would captivate people worldwide, inspiring awe and curiosity about the cosmos. Ancient civilizations often interpreted celestial events as omens or divine signs, and while modern science demystifies these occurrences, they still hold a profound emotional and philosophical impact on humanity. The brilliance of a supernova illuminating the night sky could reignite public interest in astronomy and science as a whole. Despite the excitement surrounding a possible explosion, it's worth noting that the timeline remains uncertain. While Betelgeuse is undoubtedly nearing the end of its life, the exact timing of its supernova is difficult to predict. It could occur within our lifetimes, or thousands of years from now. This uncertainty highlights the vast timescales of cosmic events compared to human life, offering a humbling reminder of our place in the universe. Until the day Betelgeuse's fate unfolds, astronomers will continue to monitor its behavior closely. Advances in technology, such as more sensitive telescopes and improved data analysis methods, will enhance our ability to observe and understand the star. Instruments like the James Webb Space Telescope and next-generation observatories will allow scientists to study not only Betelgeuse but also other red supergiants across the galaxy, providing a broader context for understanding stellar evolution. Betelgeuse's story is not just about the life and death of a single star, it reflects the grand narrative of the cosmos itself. It reminds us that the universe is in constant motion, governed by processes that create and destroy, build and transform. Every star, including our Sun, follows a path of birth, growth, and eventual demise, contributing to the ever-evolving tapestry of the universe. For now, Betelgeuse stands as a celestial beacon, its